Hello again, it's Cliff here from Down Under. In this video I'm going to go into setting up the SlantPro 15L to do another run of these ITTP, the impact tolerant touch probe arbors, the TTS style arbors, and I'll be going into tool setting tips and tricks, covering some stuff I covered early on, but going more deeply into precision tool setting when you've got to set something really accurately like a reamer. That's not an easy thing to do on a low cost basic CNC machine like the SlantPro, and there's specific challenges that relate to that type of work, shimming your gang tooling blocks into position and so on. And so I'll also discuss whether, if you're considering a SlantPro, or whether you should get a manual machine, a manual lathe. I'll go into that subject again. Is the SlantPro right for you? So when you're setting up your gang tooling blocks, you may have to change them from one job to the next. You may be changing from this type of gang tooling block to this type of gang tooling block, and so you'll need to check the alignment of it. These Tormach SlantPro gang tooling blocks are not high precision. I haven't shimmed this one up yet just to show you that the base is not parallel with the bore. Here I'm running a dial indicator over a setting gauge, and you can see over the length of that projection it's out of parallel by 0.12 of a millimeter, but that's about 5 thou over that distance. So I'll need to shim it up to the right height, but I'll also need to have a different height shim at the front than the back in order to get it level. Here I've got a couple of shims that I've engraved to compensate for that out of level. When you're setting your tooling mounting holes or your gang tooling bores, you need to shim up your blocks, for example, to get them on exactly the right center height. It's best to use a setting bar inside the bore, because that takes into account the clearance and the errors of tightening up the set screws and so on. If you work to the bore, you will have more errors in your setup. And don't use a long dial indicator stand like this, but use something as short and stiff as you can, because you get what I call dial indicator sag. The whole dial indicator sags down under gravity when you use it horizontally, and it sags down from the top and down from the bottom, so you won't be setting it exactly in line with the center line using this method of rotating a dial indicator horizontally. You'll be setting it a little bit out in the vertical, and the stiffer your dial indicator mount, the less will be this problem. Even with a short stiff mount like this, you will get some sag. Everything has flex in it. So anyway, you can use that method to sort of set it roughly right, because it's useful to set it in the longitudinal on both axes, because you can check that you've got your tooling set concentric in this direction using a dial indicator, and in the other direction by traversing the Z. So you can check that you've got it pretty right, shimmed up and aligned this way by that method, using a setting bar in your gang tooling bore. So now we have a reamer that we can dial in with a dial indicator much more easily, with that concentric bush or sleeve close fitting over the flutes. This all takes time, of course, and you can do accurate work on a fairly inaccurate low-cost lathe, but it does take a lot more time. So I've got that dialed in now with a 0.18 shim stack under the front and a 0.14 shim under the back, and I've got it within a thou or so of concentric and parallel in both directions. So that is important when you're doing precision reaming. It's not so important for drilling and other work, but if you want to do high precision reaming, you need the reamer to be concentric with the hole that's been bored, otherwise, and not just concentric but parallel to the axis of movement. Otherwise the reamer will act like a milling cutter, or it might act like a milling cutter and cut a hole that's oversized or on an angle or bell-mouthed and so on. And so if you want accurate precision diameter and parallel, you need the reamer to be accurately concentric and in line with the z-axis of the lathe. And of course this takes a lot of time, and it's only justified if you want to do high precision work. You can rely on the reamer or a drill springing into place if it's long enough and flexible enough, and if the work is not critical, but it's risky, and the only way to be sure is to get all your ducks in a line and get everything set up accurately, the tools sharp and everything dead right. So your setting sleeve or bush needs to be concentric and parallel. The inside diameter needs to be concentric and parallel to the outside diameter, otherwise you're not going to be setting it correctly. So it's a good idea to machine both the ID bore and the OD in the same setting in your lathe. Boring the inside diameter concentric means that the reamer will follow that bored concentric hole and get the diameter right but maintain the concentricity. If you just drill a hole and then ream it in a lathe, it's unlikely to be exactly concentric, and you really need it to be exactly concentric in this situation. So now you have a nice precision fit on the reamer, and you turn the outside diameter in the same setting. You can hold your tools in the gang tooling holders with TTS type tool holders, but it's better to get the specially designed tool holders, the Tormach product 37101 and 37102, this ER20 and ER16, because they have a flat for the grub screws, and you can use both grub screws to grip it on that flat without damaging the ground shank. If you're using a TTS system, you'd need to put a soft aluminium or copper slug underneath the grub screw and grip it that way. I've done a series of videos on setting your tools in the SlantPro a couple of years ago. If you're interested in that, this tool I made is very useful for setting tools that need to be rotationally aligned, like a round shanked boring bar, for example. But for most jobs, I am finding over time that the most useful tool is this D-shaped setter. You machine a diameter exactly in half, and it's quite nice having one reasonably large diameter because it's easier to align it in the vertical, and then you can set your tool at least approximately just on that face, and you can rotate it either way for internal and external tools. So it's a very multi-purpose, low-cost, quick-to-use, practical tool setter, a D-shaped tool setter where the flat is on the center line. The big advantage of setting when the flat's on the center line, or one of the many advantages, is that when you're setting up in your touch-off tables, you're just entering 0 in the XDRO, in the touch X DRO, and that's obviously setting it in the main DRO when that tool is selected. So you don't have to enter a diameter, you're just entering 0. Of course, for critical diameters and bores, ODs and bores, you'll probably need to take a test cut and mic it and fine tune that diameter. But for many diameters that aren't that critical, this method is enough. If you need to fine tune it, at least you've got it very close, and then on the first part you can tweak it in to get the exact diameter. It's very useful for setting drills too, because you can find a position on the shank of the drill that just catches the light, like this 6mm spotting drill, and then you can enter that into your well, I've already set it here into the, and you'll see it in the XDRO, 6mm there, but you'd normally enter that into their touch X, set it at 6mm. Here I'm using that special gauge for setting a tool that has a round shank, and it's very difficult to set it in the correct rotational position with the D bit type, the D shape setter, because you're never sure when you've got it set exactly in line with the X-axis. But in this situation, it's really good to have a flat surface that's on the center line of the lathe in line with the X-axis. So for that type of work, this gauge is really useful. Anyway, I'll go into this gauge in more detail in those earlier SlantPro tool setting videos. For setting your Z's, I find it's usually best to put the actual part, the actual stock in, and face it at Z0 with your main turning tool. For example, this one here, this trigon tool I'm using for OD and facing, and then index around the various tools that you're setting. When you select the tool, it automatically enters it into your tool touch off, and using a bit of paper or just directly contacting the end, enter that amount, 0.1 of a millimeter for a piece of paper, touch the Z, and it sets the DRO there at 0.1. So always using this setting facility here. You don't want to change your main DRO, because that changes all of the other tools as well. They're all interconnected. That's your work offset. You want to change your tool offset via this little series of windows here. So I just set all the Z's off the end of the stock, which is face to Z0, and then just bring in all the different tools and set them on 0 at Z0. Here I'm setting the TTS undercut tool. You know, this is a TTS job I'm machining, the arbors for the probe. So I'm setting the TTS undercut tool on Z0 or on Z.1 with a piece of paper entered up there. So all the tools are set like that. It's quick and easy to set the Z. It's setting the X that takes the time, because all the different shapes present different geometry challenges. So typically the order will be mount all your tools, let's clamp them all in the positions, then set all the tool offsets, and when they're all set, you might then check that your coolant's all set correctly. Index each tool round and check that it's getting coolant in the right place. Set up your work, and if it's got a stop and so on, set that up, and then you're ready to test out your first part. If that sounds like a lot of work, well, you're right, it is a lot of work. A CNC lathe, if you're setting up specific tools from scratch, is not a quick machine to set, especially a machine like this where there's inaccuracies and errors that you have to adjust each time with shims and so on. If you're only making one part, you could generally make it much more quickly on a manual center lathe. But obviously if you're doing production of parts or machining shapes that don't suit a manual lathe, then you need a CNC lathe. And you might be thinking, oh yeah, but once you've got all the tools set, you know, you've got 8 tools and the turret there and 2 gang tools, that's 10 tools. Surely that's enough to cover most jobs. But that's a really interesting point, and I wondered that too. But in reality, if you're doing specifically different technical jobs, most of your tools will need changing, and it will take you a lot of time. If you're making parts that are all very similar, sort of family shaped parts, and you can use the same tools over and over, then you may be able to leave all the tools and tool offsets set in your offsets tables and in your turret and gang tool positions, and that will save you a huge amount of time. And then you may be able to make low quantities of parts cost effectively, efficiently on a lathe like this. But if you're doing special work, you know, and most jobbing shops will be doing a wide variety of work, and you've got to set several tools from scratch, you've got to allow for a lot of time to set it up. And some of you might be thinking, yeah, well, that's if you want to have a turret and gang tools, but you know, if you use a quick change tool post at the front, you can have dozens of tools already preset with their work offsets, and you can just select the tool you want. That's true, that would be much quicker, but that's like a manual lathe then. You're basically using your NC lathe as a manual lathe, and you manually have to change each tool. It won't run automatically unattended with the quick change tool post and tool holders. You need a turret and gang tooling for it to run automatically unattended. And the whole point, to me anyway, the whole point of a CNC lathe is that it runs automatically unattended, so you can go away and do something else. If you're going to have to hover over it and clear out the swath and change your tools manually, then you might as well have a manual lathe. Because on a modern manual lathe you also have a DRO with offsets, just like a CNC lathe. You can select whatever tool you want, and it automatically has the X and Z offset table within its DRO, and so you can have a whole lot of quick change tools and to go in your quick change tool posts. And if you're manually doing the work, it's just as quick on a modern manual lathe. I know I've talked about this in other videos, but I think it's a very key point that's easy to overlook. If you're considering whether to buy a manual lathe or a CNC lathe, this is a really important key point to remember. Compare it with a modern manual lathe with the tool offsets and the quick change tool posts, and you'll see that you really need to be doing quantity or volume production or machining shapes that don't suit a manual lathe in order to justify a CNC lathe. Don't get me wrong, so far I'm really pleased with the SlantPro. For the money, you know, it's good value for money. It's so far it has been reliable and repeatably accurate, so that as long as it's repeatable you can set the accuracy, and I'm able to do that. I don't know how it'll be long term. I don't know how reliable it will be or how it will wear. Only time will tell that. But so far it's been going really well. Alright, thanks for watching, guys. I try and release a video about every 2 weeks on my workshop and Tormach machines. If it's of interest to you, you can subscribe and you'll get notifications if you click on the little bell icon. Thanks for watching. Cheers.